Okay, welcome back. Let's look at similar shapes now, right? Now, two shapes are similar if they have the same shape but not necessarily the same size. So what are we trying to say is, let's look at A. See the shape here now. It looks like this shape looks kind of like it, but it's not exactly the same. That's why I mentioned before that similar shapes are similar, but they're not the same. For example, now let's look at angle B. B 85, F 85. Let's just go around really quick, right? 85, 25, 90, 85, 25, 90. Then we got 60 over there at the bottom. So the angles, what can we conclude? The angles are the same. That's what they told you here, right? Right. That's what they're telling you here, that the angles are the same. Angle A is equal to angle E. Angle A 125, angle E 125, right? Then they want you to look at. Okay, now they want you to look at EF over AB. EF over AB, right? So EF is 40, AB is 20. So it's 40 over 20 will give us 2, or 2 over 1, right? So there is a ratio. So we got like a ratio using just these two corresponding sides. Let's look at the next corresponding side. I think we can clearly see that the next corresponding side, let's take this off. Let's take this BC, and we can just see that its corresponding side is going to be this FG. Now, in our first one, we took the, see, look, I'm looking here now. Here, we took the bigger, let me try and zoom in and have both on the screen at the same time. There we go. Right, we took the larger image over the smaller image. See the 40 over 20? That's what we did there. Now, we must stay in that pattern now. We must take the larger one over the smaller one. So the larger one here is the FG and the smaller one is BC. FG over BC would give us this 94 over 47. Put that in your calculator. Let me just get my calculator. Right, so if you don't trust me, here we go. 94, what is this? 94 over 47 is 2, right? Oh, we said 2 over 1. I'll tell you why I'm saying that just now. Okay, so here's the conclusion. The corresponding angles are equal. Angles are equal, and the corresponding sides are in the same proportion. Now those are the two instances of similarity. Now when you're dealing with shapes, see, we're just starting off the section and we are dealing with different shapes, right? Polygons are shapes. You're dealing with similar shapes, right? When you're dealing with shapes, both need to be shown there. Both that the angles are equal and the corresponding sides are in the same proportion, right? When you're dealing with shapes, just now we're going to go into triangles, and that's just one tiny difference there, right? Okay, same thing with the rectangle. Same thing with this rectangle. They show you that all sides, all these corners here are 90. They show you the corresponding sides. Yes, okay. Now, this is why I told you to write it down as a fraction. Write down your ratio always as a fraction. AB over EF. AB, we are talking about AB over EF. Now, in the previous one, I took the bigger one over the smaller one. Now I'm taking the smaller one over the bigger one. So AB is 30, right? AB is 30 and EF is 60. So 30 over 60 will give us 1 over 2. That's our ratio. Can you see that our ratio is the same? Half, 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 half. The ratio is half, right? So what can we conclude? The corresponding angles are equal and the corresponding sides are the same, in the same proportion, right? So these two shapes here are similar because angles are equal. It's corresponding, see, the angles are equal and with the sides are in proportion, right? Okay, let's move on to the next one now. Consider the two polygons below, right? So now something that we can notice immediately is that we have 90 degrees on all the corners, right? We have 90 degrees on both the shapes, so we can conclude that all the angles are equal. All the angles are equal there, right? Now let's look at the sides. We finished with the angles. Now let's look at our sides. When it comes to our sides, let's see, we got EF over AB. EF over, we've got EF over AB, that is 60 over 20. 60 over 20 is 3. Then let's take FG over BC. Take this off. FG over BC. Now we take the larger one over the smaller one, so 40 over 20. Now can you see this here? Let me zoom in and show you this, right? Can you see one of my ratio gives me 3 or 3 over 1 and the other one gives me 2? This immediately is going to tell you that the sides are not in proportion, right? The ratios of, there we go, the ratios of the corresponding sides are not the same, right? They are not the same, so these two shapes are not similar. Okay, it says the polygon EFGH is not an enlargement of polygon ABC. It's not an enlargement, right? In similarity, the shapes are similar, they are just enlarged, right? Okay, now consider the two polygons below. All right, now let's look at this. If you look at this shape, just looking at it, even if you grade R, this shape is not the same as this shape here at all. This here, ABC, is going outside, right? And this thing here is pointing inside the shape. Okay, can you see that this is not the same shape as this, right? Then let's look at our angles. 65, 115, no. Yes, we got a 90. Let me get my highlighter. Yes, we got a 90 here, 90. We got a 90, we got a 90. But when it comes here, this is not working out, right? This is not working out. Get my pen. Alright, there we got different highlighted color. This 65 is not equal to this 115. This 230, this is not equal, right? That is what they're telling you, a long story, right? Then if you look at our sides, I can't get this in one view, but okay, what I'm trying to say is, let's say if we take the smaller one, if you take the smaller one, 20 over 40 would give us 1 over 2. 20 over 40, 1 over 2, right? We got the half. Here, 20 over 40, 1 over 2. Our 30 over 60, 1 over 2. If you do the rest of it, you're going to see that all our answers are 1 over 2. So what can we conclude now? If we get all our ratios are in proportion, but the angles are not equal, then these two shapes are not similar. Okay, then you would have to do exercise 6. Right. Remember in exercise 6 now, remember, you have to prove that the angles are the same and the ratios are in proportion. Exercise 7, rhombuses. Okay, same story. Right. Now here's a big section that we're looking at. Similarity in triangles. Alright, let's look at similarity now, right? So, yeah, okay, there we go. Alright, similarity, we're looking on page 166. So now triangle DEF, I'm reading here, is an enlargement of ABC. The two triangles have the same shape and therefore are similar. Let's investigate. Alright, we've got a 78, angle A is equal to angle D. We got angle B 69, angle D 69, angle C 33, F 33. We can clearly see which angles correspond with each other, right? We definitely know that the angles are corresponding. Now let's look at the sides. They took the bigger one over the smaller one, so 50 over 25, we got 2. 88 over 44, there's our 88 over 44, we got 2. Right? Then we've got the 84 over 42, this one line going this way, over that, 84 over 42, we've got 2 over 1. Right? So the conclusion, ABC and triangle ABC and triangle TEF are similar since the following conditions are true. They're showing you the angles are the same and the ratio of the sides are the same. Now here's a good one. I want you to look at this part here. Yeah, okay, I want you to look at this part here now. Now you see, if you put the bigger one, let me try and zoom in to get this in a better frame. Right, see, if you put the bigger side over the smaller side, 50 over 25, we got 2, or we can say 2 over 1. We can also say the smaller one over the bigger one and have 25 over 50 and get half. As long as you show me what the teachers are looking for, both are accepted, right? But just show us one of them, right? If you show us, the teachers are looking to see, there we go, right? The teachers are looking to see that you have it in ratio, that this is the answer to this is 2, 2, 2. The teachers are looking to see, let me get a different, what can I use, there we go, that we've got the half, half, half. That is what we're looking for, right? Now remember, it's either you give me this part here on the top, or you give me this one here at the bottom. If you give me both, I'll just accept whichever first one that I see there, right? That's a marking rule. So note, now this note is very important. This is what I was looking for, right? Then okay, long story short, you can read this, right? I don't want to read it and then try and confuse you. What we're trying to say here is that if no two triangles which can have corresponding angles equal with the ratios of their corresponding sides being unequal, meaning if I have a triangle, right, and if I can see that all of the angles are corresponding here, it doesn't matter for you to go and look to check if the ratios are in proportion. In a triangle, this only happens in a triangle. In a triangle, the ratios are automatically going to be in proportion, right? That's what they're trying to say. There's no way, what they're saying is there's no way that these angles can be the same, but the sides are, the proportions are the same. There's no way, right? So if you just manage to prove that angle is the same, there we go, you prove that the triangles are similar. Okay, how to name the similar triangles? The only thing different from the previous exercise is that this has those 3 lines going down, right? That's the only thing different. Okay, so let's look at page 167 now. Example 13. Show the following triangles are similar. Now, yes, I can. Okay, right. There we go. Now, in triangle AEB, CED, that's what I'm talking about. Angle A and angle C are equal. Given. So, we talk about angle AC, we got the dot there representing. Angle C, we got the dot given. It was given to us, it's on the diagram. E1 is equal to E2. I'll also accept given there because it's given, it's shown that it's 90 degrees, but they're saying both equal to 90 degrees, right? That's also accepted. Then B is equal to D. Angle B is equal to angle D. Why? Sum of angles of a triangle, because this would be the angle D would be 180 minus whatever this is, minus that. Okay, let's say minus dot minus 90. B would be 180 minus dot minus 90. So it's going to come to the same thing. And this should be your reason as to why. Then we can conclude now. Triangle AEB is similar to CED. Let's double check that. AEB. Now we went from the dot to the 90 to where there's no angle. Dot, 90, no angle. Now we need to find that corresponding here now. Dot, no, there's no angle there. So we need to go dot, let me get my pencil. Dot, 90, no angle. Can you see that? So we went CED. That's how we named it, right? Then our reason. Let's go to the reasons sheet here. Oh, there we go, right. Okay, I can't fit that. Let me just get that. All right, there we go. If two triangles are equiangular, meaning the angle. The reason there is the angle. Like this here. Equiangular. We can give the reason as similar triangles are accepted. Equiangular triangles, right? And then we are about to learn about when the sides are in proportion. You say sides of triangle are in proportion. We are about to learn about the proportion. Let's learn it now. So we've got ABE and we've got CED here, right? Now, yes, they tell you to redraw the triangles. Since you're starting off, you can definitely redraw your triangles because it helps you visualize better. So you drew this triangle AEB. Then what I'm saying is that this triangle here, we rotated it to make it look like this A, right? And also okay, I got my pen sorted up. Also, this triangle here, they rotated it so we can see it look like this. The reason for doing this, let me just move I can't move my camera. Maybe I can move this window. There we go. Right. Now the reason for doing this is so we can put these two triangles, this and this, right next to each other, so we can clearly see the ratios. We can clearly see. Let me take out this drawing so we can see. Right. We're doing this so we can clearly see that AE corresponds with EC. Right. And okay, I'll solve the pen story later. And AB corresponds with C. What is this? D. Right. That's what we did that for. Then we look now in triangle ABE. Okay, it looks like this page is giving me a lot of trouble. So AE over CE, AE over CE. So we're taking a smaller one over the bigger one. Remember, I keep on saying this so we don't forget. Sometimes what learners do is they go and take, as they do the smaller one over the bigger one, they go do the bigger one over the smaller one, somewhere in the second or third step. So we can see now that we always getting these answers here, right? All of this was given to us, meaning the information is already on our sheet there. Now, therefore, they're showing that all of these ratios are in proportion. Triangle AB, corresponding sides in proportion, right? So yeah, that's the proportion one. You would have done exercise 8. Lovely exercise 8. Right. Whilst we're just looking at exercise 8, it's on the page here. I want, since you're starting off, right, you are going to be doing ones like this, but I need you to be at a level to sort this here out. I want you to see now, ABC, ABC. We're talking about this triangle here, that triangle, and ADE. You must read the question, eh? ADE is this triangle here. I want you to be able to look at that. Right? Those are exam type of questions. Alright, so you would have completed that exercise. Now, example 14, what page are we on? Let's check. 167, right? Example 14. Okay, example 14. Sorry, right. So we've done proving that the triangles are similar. Now, what if they tell you that these triangles are similar? Calculate the value of x. Definitely exam type question, definitely. Now let's look at this. In this case, you find an existing ratio, right? You find an existing ratio. Now you can see that this AC corresponds with CE, right? So if I take 3 over 9, I get 1 over, change my color, maybe this might work out, I get 1 over 3, right? That's what you get there. Then yes, then if we take BC over CD, that's 2 over 6. 2 over 6 is 1 over 3, right? So if you look at that, that's what they did here. They're showing you that when they took two existing corresponding sides, we got an answer of 1 over 3. That's what they told you here. So what they're saying is, so far we're taking the smaller one over the bigger one, smaller one over the bigger one. So we're trying to say that this x over 12 should give us 1 over 3. That is what I'm trying to say here. When we took 2 over 6, it gave us 1 over 3. 3 over 9, 1 over 3. X over 12 should give us 1 over 3. Now what we realize now is that we have an equation here. Okay, yeah, all right. Now this is using a different method that I don't really use, but let's go with it. Then I'll also show you my method. Now we got x divided by 12. The opposite of x divided by 12 will give us x over 12 times 12. So what happens here is, let me change my pen color. What happens here is that this divide by 12 is cancelled out by the multiplied by 12. I'm left with x. So my x came down. Then 1 over 3 times 12. You don't trust me? Let's go here. 1 over 3 times 12. There we go. 4. Right? So x is equal to 4. Right? My method. Okay, yes, almost forgot about that. Let's check my method now. So if I'm left with x over 12 is equal to 1 over 3. I cross multiply, right? Meaning I'm now going to have x times 3 is 3x. Okay, so I'm saying 3x is equal to 12 times 1. Then I divide the side here by 3. See that this works. Right, there we go. Then I divide the side here by 3 to cancel. I'm left with x side. 12 times 1 over 3. We're not sure. 12 times 1 over 3 would give me 4. Right? Would give me 4. I actually agree with the book. I think the day method is a bit easier here in this specific case. But the method that I use, we use it for more complex equations later on, right? So that's the end of that, and we have exercise 9. Right, you have to sort out exercise 9. Look at the Excel sheet, you'll know which ones to do there. Then your revision exercise. Now your revision exercise, I did it myself, and it's a bit tough for newcomers, right? For people who are like grade 9, grade 8 learners, and expect one of this in the exam. Right, now I did give you all because you need to get used to. The reason for doing that is you need to get used to seeing a shape that looks like this, a parallelogram. Let me get my highlighter. You need to definitely see that the parallelogram. It is definitely there, right? Parallelogram is there. Special cases, if you start to see traps. Not actually a special case. It's rare to see a trap. Isosceles. I need you to get used to how in an exam type question you see an isosceles triangle, right? And how that'll affect us, meaning that these base angles here, let me just change this. These base angles are gonna be equal, right? So I did this equally. There we go. Let's just look at this while it's on the screen, right? QRS is an equilateral triangle. QRS. Immediately we're gonna now know QRS equilateral. So this here is, the sides here are equal. We also know that this angle here is 60. This is going to be 60, and this is going to be 60. Can you see? The reason this is the most important exercise, I just need to tell you that, is that in this revision exercise, you really test all that you've learned in the section here. This is going to close it up. In our next video, I'm going to do the full correction for every single thing here, right? So, yep, quite a good exercise. You don't have to do the sum challenges, okay? Alright, thank you, that's all for now.